Okay, so in this video I'm going to give you steps for graphing a rational expression, well, just graphing in general, but these are the steps that we're going to be going through in this problem. So take a look at the function f of x. I provided you with the first and second derivative to make life a little bit easier in this problem, but in step number one we typically find the domain. So in this function, in this particular problem, we look at the original function, which is f of x equal to x plus 2 divided by x minus 1, and to find the domain we have to figure out what makes this function undefined. So we're going to look at the denominator. We're going to say the denominator would be equal to 0 when x is equal to 1. So this is bad, sort of, because it makes the denominator equal to 0, and dividing by 0 is not allowed. So the domain is going to be basically all the real numbers except for the number 1. So 1 is a bad value. It makes the denominator undefined, or it makes the denominator equal to 0, which makes the function undefined. So 1 is going to be considered a critical number for the rest of the problem. Okay, so when you're doing the first derivative critical numbers, second derivative critical numbers, automatically 1 has to be part of that. Okay, so let's continue by finding the x and y intercepts. So step 2 is to find the x intercepts and the y intercepts. So there are two kinds of intercepts. Let's start with the x intercepts. To find the x intercepts, we usually gonna make we're gonna make the y equal to 0. So we're gonna say let y equal to 0. So in this problem, the f of x is x plus 2 divided by x minus 1. The y is the f of x. So it says x plus 2 divided by x minus 1, and we're going to erase the y and replace it with 0. So this is equivalent to saying we want x plus 2 to be equal to 0, because if you think about it, there's a 1 underneath, so we can cross multiply, and when you cross multiply, the 0 times x minus 1 goes away, and so x is going to be equal to negative 2. So far the point is, the answer is negative 2 comma 0. Okay. Now, this is the first kind of intercept. There's another kind of intercept called the y-intercept, and to find the y-intercept, we're gonna let the x become 0. So it's always the opposite letter. So again, your function is f of x equal to x plus 2 divided by x minus 1. You're gonna have to erase the x's everywhere and replace them with basically the value 0 and see what happens. So in this case, you end up with 2 divided by negative 1, which is at the end negative 2. So the answer here is going to be 0 for the x and negative 2 for the y. So far I know that if I graph this function f of x, I know that it's going to cross the x-intercept at negative 2, 0, so somewhere over here, and I know it's going to cross at 0, negative 2, so somewhere over here on the y-axis. So that's what I know so far from these two answers. Okay, next we have to look at the asymptotes of the function f of x. So we have three different kinds of asymptotes: the vertical ones, the horizontal ones, and the oblique or slant asymptotes. So let's start with the vertical asymptotes. Since my domain was all the real numbers except for negative 1, positive 1, that tells us automatically that x equal to 1 has a VA. So this is a place on the graph where we cannot cross a vertical line. So what about the HAs? So in this problem, we're going to take the limit as x approaches infinity on this function f of x, and the limit is going to be as x approaches infinity of x plus 2 divided by x minus 1. Since the degree on the numerator is 1 and on the denominator is 1 also, we will end up with the 1 divided by 1 as the answer to the problem. The coefficients basically are the solutions. So this is again 1. So this tells me that y equal to 1 is a horizontal asymptote. So this is the horizontal asymptote, and x equal 1 was the vertical asymptote. Okay. Since there's a horizontal asymptote, automatically they're not going to be slant asymptotes. So the slant or the oblique asymptote does not exist because we have a horizontal asymptote. So you cannot have slant and horizontal at the same time. It's either one or the other one. So if you already have a horizontal, you're not going to have a slant, and vice versa. Okay, so now for the max min increasing decreasing intervals of the function, we will need the first derivative. The problem gave us the first derivative. They told us somehow that it's negative 3 divided by x minus 1 squared. You can look back and see this. It was provided in the question. So the question is now, well, what makes the derivative equal to 0 and what makes it undefined? So when is the derivative equal to 0? And this does not happen because on the numerator we have negative 3. So negative 3 can never be equal to 0 because it's already negative 3. Well, what about what makes the derivative undefined? And that happens when x minus 1 squared is equal to 0. So this is true when x is equal to 1, because when you put 1 right here, 1 minus 1 is going to be 0. 0 squared is going to be 0 still. So the critical number is 1, and that's kind of what we said at the beginning of the problem. We said 1 will eventually show up as an critical number everywhere for the rest of the problem. So here we go. Now we have the number line and plus infinity on one side, minus infinity on the other side, and this is the first derivative test. Okay, we're going to put 1 in the middle, and because of this, we're going to test some values before and after. So let's test 0 and let's test 10. So what would happen if I test 0 and 10? So in both cases, whether it's a 0 or 10, the function is decreasing, which unfortunately means that there is nothing, no maxes, no mins. By the way, since 1 was not part of the domain, for these problems, typically what I like to do is put a little circle right here instead of a tick. This reminds me never to call the 1 as a max or min. Remember, the 1 was missing from the domain, so if you look back over here, x was not allowed to be equal to 1. So you cannot label it as a max, min, or inflection point, okay? So that's important. To remind me of that fact, I usually put the little circle over here on this line, basically. Okay, so when is function increasing or decreasing? It's pretty much always decreasing from negative infinity to 1 and from 1 to infinity. And there are no there are no maxes and mins. So on to the next step, which is the inflection point step. So in order to find the inflection points, I need to know the second derivative, and again, thankfully they gave me the second derivative. So what was the second derivative? It was equal to 6 divided by x minus 1 cubed. And again, let's find out what makes it 0, what makes it undefined. So again, there's no way on earth that the second derivative can be equal to 0 because of the 6, but it can be 0 when the x is equal to 1. And let's go ahead and make the line again for the second derivative. So here we go. This is what the line test is going to look like when you plug in 0 or 10, for example. The 0 is going to give you a negative value, whereas the 10 is going to give you a positive value, and so the function is going to be concave down, then concave up. And unfortunately, since the 1 is missing from my domain, I cannot have 1 be called an inflection point. So there are no inflection points, basically. So there you go. I recorded that the function is concave down from negative 1 to 1 and concave up from 1 to infinity. And unfortunately, there are no inflection points because 1 is not in the domain. Alright, the final step is to put everything together on the graph, and in order to do that, you may have to make a table sometimes and get some additional points that belong on the graph. But for now, we know from the X Intercept and Y-Intercept step that there are intercepts at -2, 0, and 0, -2. So we know that the graph is crossing through these points. 1 did not belong in my domain, so 1 is going to have a vertical asymptote. Let me go ahead and draw that. So there you go, 1 is a vertical asymptote, and there was also a horizontal asymptote. Let me go ahead and add that to the graph. It was y equal to 1 also. Okay, so there's the asymptotes, and what we should know is that the function begins and ends next to asymptotes. So it's either going to start kind of like over here and end over here, or start below and then end below, start up on top, end here, or start here and end there, basically. So those are the 4 options, and what we have to do now is figure out which one of those is the right one. So for this first section of the graph, it seems kind of obvious that we should start probably down below the 1 and kind of go down this way, kind of towards the bottom of the graph, because of the way that the function is crossing the x and y intercepts. And we also know that the function is decreasing on that interval. As a matter of fact, it's decreasing all the time, so it's decreasing here, and it has to be concave down because of the second derivative. So putting all that stuff together, we get some graph that looks sort of like this. So make it as smooth as possible, passing through those 2 points and kind of close to the asymptotes at the beginning and at the end. So that's what the graph is going to look like here. And on the other hand, after the number 1, again, we're decreasing, and it has to be concave up. So the only way to do that is to start from here and kind of come down this way. Again, I don't have super accuracy, and if I want more accuracy, I can plug in, for example, 3 into the function to figure out how high the number is going to be, if it's here or there, and then a graph accordingly. But, you know, we're just making a sketch, and this is good enough for now. So on to the next one.